Hello friends, myself Shriram Korde. Welcome to another video. In this video, we are going to look at some more example with respect to functions. Now here, we would like to develop a function which will basically give us prime factors. So I have basically created the rough skeleton ready so that we don't have to keep on typing lot of things. The basic things are kept ready, like entering a number and scanf. So that has been done. Now let's try to understand what do we mean by finding prime factor. So let's see this with an example. Let us say that I have a number 48. Then if I have a number 48, then essentially I will divide that particular number. I will start basically from 2 and then I will go on till say 8, 9 like that. Okay. So the way in which we should be doing is we would like to get those factors which form that number. So let me explain you with this example. So what will happen is if I divide 48 by 2, then what I get is 2 into 24. That means 2 was able to divide 48. Then when it comes to 24, so that means now what remains is 48 I have divided by 2. So what remained basically is 24. Now to 24 I am going to check again from 2 onwards. Okay. So to 24 when I do, so I will basically get 2 into 12. Then similarly I will basically have, that means what I have now is 2 into 2 into 12, because essentially it's going to give me 48. Okay, so that is 2 into 2 into 12, then 2 into 2 into 2 into 6, and then what now have is you have basically 6. So 6 now once again you are going to divide. So what you get is 2 into 2 into 2 into 2. So basically what you got is these three twos, then this 2 into 3. That means now here you can see 4, 4 into 2, 8, 8 into 2, 16, 16 into 3, 48. So these are basically the prime factors when it comes to 48 number. Similarly, if it would have been only 24 number, if somebody gives me an input 24, then what will happen is, that means I will have 2 into 12. Then obviously from there onwards 2 into 2 into, basically like you will get 6, and then 6 once again will be broken into 2 into 3. Now suppose if you get a number like say 35. So let me just write this completely. So this is 2 into 2 into 6, and then you have 2 into 2 into 2 into 3. So that is 24. Now 35 you first divide it with 2. So obviously 2 you can't divide. Then you proceed forward. You divide it with say 3. Then again 3 you can't divide 35. Then you go to 4. You can't divide 4. Then you divide it with 5. So obviously 5 it works. So 5 sevens are 35. So essentially your prime factors now are 5 into 7. Why? Because now 5 you cannot further break it. Similarly 7 you cannot further break it. So that's the way typically you want the prime factors for a particular entered number. So these are the prime factors. That means 2 is 4 times and 3 is once. Similarly when it comes to 24, 2 is 3 times and once 3. And when it comes to 35, 1 times 5 and 1 times 7. So that's essentially the prime factors with respect to a particular number. So having understood this concept, now we need to write a function which will do this job for us. So what I have done is, as I mentioned to you earlier, this is a number n. I want a user to enter that particular number. So we will do scanf, and then we need to write a function prime factor. So for that I have done the declaration, and it's going to take only one number, that means the input number. So that we are going to pass, and then this function prime factors should print all the prime factors which basically you will obtain by a particular algorithm or a particular code. Okay, so now we need to develop this scheme, or we need to develop this algorithm. That means now what we need to do is we need to take the number and we need to divide it, start from 2, proceed till 9. Okay, so when you do that, then obviously what you require is you need to do it in loop, and then you first check whether there is a remainder. If there is remainder is 0, that means that particular number has divided it, and then you basically show that number. Okay. Otherwise, what you do, basically you proceed forward, like the way in which I have told you with 35. Like you divide with 2, it didn't work. Then you proceed to 3, then it didn't work. When you proceed to 4, it didn't work. Then when you proceeded to 5, it worked. Okay. So like that you basically are supposed to do. And how long you need to do? As long as the ending number is not 1. Why? Because when you enter a positive number, so obviously here I am telling you it's a positive number. Okay, positive number is the input. Okay, so positive number is input. So that is obviously it is understood also, but I am just repeating it. So positive number is the input. That means you keep on dividing with the factor, like the way in which here you did it. So you divided by 2, so you got 24. So then 24 once again you divide it with 2, so you get 12. That means you continue this as long as essentially you basically don't get 1. Okay, so that's the important point. That means at each stage the number gets divided as long as it is a successful division. Okay, so that's what basically the overall thinking is. So let's now try to write this program. So what you now require is you start with the starting number. Okay, so I will say that, okay, the starting number, and let me just put here starting number. So the number that you want to divide, so I'll just have a no. Okay, some number basically. Okay, so you will have this number, we will initialize this number 2, because you will start this division from 2 and then you basically write. So how do you write it now? So you have a while loop. Okay, and in the while loop, as I have told you, you need to write a while loop. So how do you write? So in the while loop, obviously you have to write a logic, so that we will develop. If the number, whatever the n that has been entered by the user, basically you divide it by whom? So that means you are going to use modulus sign, and you are going to check the remainder. So you have this n mod of no. So here you will say basically 0. Okay, that means if it is divisible, then what you do, you simply print that particular factor. Okay, so you simply say percentage d and then that particular number, whatever the number, because you started with no was initialized to 2. Okay, so this is the basically the if portion. Otherwise what you do is you basically are going to continue. Continue means what? So you need to because you need to just start, that means what you have done is you started with 2, so you will continue, in the sense you first increment it and then you need to once again do it in the while loop. Okay, so that means now you first increment the number. So you just do no plus 1, that means you increment it by 1, no plus plus you can write. And then what you do is you don't want to do anything in this loop. Why? Because now it's not divisible, so you need to proceed, and once again you need to do this modulus sign. Okay, so that means now here you will write continue. So when you say continue, we have learned continue, so the next lines whatever in the code they come, they will get, they will not execute. Okay, if when you want this to be executed, that means this number you first check the remainder is 0. Now I told you, you are going to do this like 48 you divided by 2, so it remained 24. Then 24 was divided, so you essentially got 2 into 12, like that. So that means what you basically have is, you don't want this, when you say continue, you don't want the number to get divided. Why? Because it didn't succeed, that's why it has entered into else. So what should now happen is, you basically have this n which was sent to you, so you are now going to divide n by whatever the number that that particularly was written. Why? This continue is will not basically execute this line. Why? Because as you know, continue will basically go to this last curly bracket, and from there it will go to the while loop. That means this statement will get skipped. However, when there is a equal to 0, that means the remainder is 0, that means it's a factor, so that particular time we should divide it, and that's why n is equal to n by no. That means now here, if the number would have been say 48, then this number will become 24, then this number will become 12, like that it will keep on continuing. That's what I'm trying to tell you. So n is equal to n divided by number. Okay, so that's what you do. Now here the issue is what is the ending condition. So as I told you, n should not be equal to 1. n should not be or n not equal to 1, basically n not equal to 1, that is what important. Okay, so why? Because now then in the end what you will get is 2 into 2 into 2 into 2 into 3, that means 6 is 2 into 3, then further you is like 1, that means the last one is 1, that means you don't require that. So that is what it means. So n not equal to 1, essentially when you keep on dividing it, so n should not be equal to 1. So that is the logic, and you otherwise you are going to print the factors, and you basically are done. So now we need to call this function from here, prime factors, and we will pass this number which user enters by doing scanf. So I hope this is understood now, this logic is understood. So now let's run this code now, so that we should see how it is performing. I hope the things are appropriate now. Continue and number plus plus, and number was initialized to 2, right? So we'll enter a number. Right now we will enter say 24 only, because that number we know. Yeah, so this is 2 into 2, 4, 4 into 2, 8, 8 3 are 24. So this is working correctly. So let me enter say 35. So this 5 into 7, that is correct. So let's enter some other number, say 39. So 3 into 13. So that is what basically I'm trying to tell you. So 3, so that means you started with 2, 2 it didn't work, 3 it worked, and what is 3 into 13? So 13 is the last, and that's where. So now you will see the way in which it has worked, like 39. Let's take this and understand the code. So when the entered number is 39, so you divided it, basically you started with 2, and basically 2 n mod 2, that means 39 mod 2 is not equal to 0, so obviously no was made 3, and then it continued, it came back, then obviously n is not equal to 1, it still is 39, so 3 mod of 39 mod of 3, so you basically it is 0, yes, so that's why it printed 3. Okay, then it divided it, that means here you got 13. Okay, so n became 13, so 13 once again it came here, 13 mod of what? So essentially you basically have this particular thing, so it is, you will reach this end. Why? Now here particularly what will happen, so let's do it once again. So here let me put it here 39, so 39 was the input, so 39 mod of 3. Okay, so that means here you got NO. So NO was 3, so it printed 3. That means here you got printed 3. Then obviously it will not enter. So then N became 13. Why? Because this 39 divided by 3. So this N is 13. Okay, so here N becomes 13. So now let me just write it here. So N becomes 13. So this 13 mod of what? Basically. So 13 mod of 3. Why? Because NO was still 3. Okay, it didn't enter into this. So it didn't divide. So it didn't print. So NO became NO plus plus. So it became 4. Then it continued, N was not. So 13 mod, like that it will happen. And then finally what will happen is that, so you are going to have this condition where it will basically become close. It will not have that particular, this one 13, then it didn't divide, so 13 it will continue, because 13 is a prime number, so it will keep on happening till what? Not equal to 1, then it will essentially reach 1, and that's where it basically the loop will end. Okay, and that's why you got 1 finally. Okay, so that means n mod of 1, so it's 13 mod of 1, and that's why you basically are going to get 13 getting printed. Okay, so we can see this if I put say debug, if I just put debug here, and you will understand what I'm trying to do it. So let's debug this code. So let me just clean this up, all the things, and now we will debug this code, and let's enter 39. So here let me enter 39. So now you will see this, and let me put here watch. So the entered number by user, that means the n is 39. Okay, then we will put watch for NO. These are the two things which are important for us. Yes. So here you will see this. It has gone into this NO. Enter number 39. So let's continue. Okay. So here you will see this 30. N is still 39, and now it is 13. 3. NO is 3. Okay, because it incremented. 2 it didn't work. That's what I told you. So now 3. So 3 it will basically. So here it is printing 3. So that's why you see now the 3 getting printed at the bottom. So that is what I wanted to show you. So 3 got printed. Okay. So let's continue. Now you will see. So this particular thing again it entered here, and that's what it is 5. Okay. So NO is now 5 because 4 then 5 it happened obviously here. Here you can see this 5. Then we will. I'm just stepping it out. Okay. So I'm just 6. Then 7, then 8, you still n is 13, okay, and then you will see this 9, 10, 11, you will see, let's see the watch on the left hand side, 11, then 12, and then 13, and that means 13 mod of 13, that's what I told you. So 13 mod of 13, obviously your what will happen, so this will print 13, so now 13 will get printed, then it will come out, and it has come out. Okay, so that's the way typically this particular thing happens. So I hope you got this concept about prime factors, and you understood the way in which this scheme works also. Thank you.